Hello everyone. Today again we are together for a new class, and today we will discuss an important topic about the kinetic theory of the gaseous molecules. In this chapter, actually we will discuss the important multiple choice questions regarding any exam point of view. We should start. The first question is that the root mean square velocity of a certain gas 827 degree is a zero point 0.3 meter per second. Its root mean square velocity at 927 degree is first option is a by 2 meter per second. Second is 2a meter per second. Third is 3 meter per second, and D is zero point 0.6 meter per second. So the right option is option number D, zero point 0.6 meter per second. The question second is that the real gas show nearly non-ideal behavior at low pressure and low temperature, high pressure and low temperature, high pressure and high temperature, low pressure and high temperatures. From these option, on these four option, the right option is D. Low pressure and high temperature gas behave like non-ideal behavior. Which one of the following is true for the virial equation of a state? First option is virial coefficient or universal constant. B option is that the virial coefficients, and the third is virial coefficient are function of temperature only. And for the D option, for some gases virial equation and real gases equation are same. From these four options, and the first three options are similar with each other, but the most accurate option is C, virial coefficient or function of temperature only. Then we can move. We should move the question number 4. The curve of compressibility factor Z is a straight line for the nitrogen gas, all real gas, all ideal gases, and the right option is option number D, all ideal gases. Which gas show highest positive deviation at high temperature and low pressure from oxygen, carbon dioxide gas, nitrogen, and hydrogen? From the option, first option is oxygen, second option is CO2, third is N2, is H2. So approximately near the option is closely accurate option is N2. From the graph, when we see the graph of oxygen, CO2, N2 and H2, so the right option is C, N2. Which one of the following laws is applicable for the behavior of perfect gases? First option is Boyle's law, second is Charles' law, third is gas law, and D is all of above. So the right option is D, all of above. Seventh question is that an ideal gas is compared to real gas at very high pressure, occupy more volume, less volume, small volume, and none of above. Actually, this is option number B. Option number second is right, less volume. For eighth question, according to kinetic theory of the gas, the absolute temperature is attained when volume of a gas is zero, pressure of a gas is zero, kinetic energy of a molecule is zero, specific heat of a gas is zero. So the right option is D, specific heat of a gas is zero. For question 9, find the ratio of the average kinetic energy per molecule of oxygen and hydrogen. 1:2 ratio, 1:1 ratio, 1 ratio 1:6, 2 ratio 1. So from these four options, the right option is B. Every molecule of oxygen and hydrogen have a same average kinetic energy per molecule. So the right option is B, 1:1. The 10th question is about a container. Suppose a container is evacuated to have just one molecule of a gas in it. Let's V and VRMS represent the average speed and RMS speed of the molecule. So V A is greater than VRMS. VA is average velocity of a molecule, and VRMS is a root mean square velocity of a gas molecules. Average velocity is greater than root mean square velocity, average velocity is less than root mean square velocity, or average velocity is equal to the RMS, and D is RMS is undefined. So the right option from these four options there is C. The average velocity is equal to root mean square of the root mean square velocity of the gas molecules. 11th option, which one of the following is not true about for the ideal gases? Pressure of the gas is due to collision of a molecule with walls of container and with each other. B option, random motion of a molecule. C, follow the general gas equation. D, molecules show elastic collision. So the right option from these four options, first one is a right option. Pressure of a gas is due to collision of molecule with walls of container and with each other. What of the which one of the following is not true for the nitrogen gas contained in a container at a STP? All the molecules have same masses. All the molecules possess kinetic energy. All the molecules have same velocity. No molecule is stationary. So the right option is C. All molecules have same velocity. So this is a right option. And which one is not correct for the PV over RT? It is compressibility factor. It is constant for the ideal gas at STP for any volume. It is variable for the real gases. None of these. So the right option is none of these. Deviation of a gas from the ideal behavior does not depend upon the molecular volume, pressure applied, and intermolecular forces, none of these. So actually this is also a D option, because these deviation behavior all are factor are dependent: molecular volume, pressure, applied pressure, intermolecular forces, the ideal behavior, and also depend upon these factor. So option is D, none of these. Fifth, gases cannot be compressed to zero volume because these are incompressible. B, these have repulsive forces. These volume have non-zero volume. All of these. So the right option is C. These molecules have non-zero volume. According to kinetic molecular theory, the gas molecule increase in kinetic energy when they are melt from solid to liquid or mixed with each other. Each molecule at low temperature are frozen into solid or considered into liquid. So the right option is option number A, are melted from solid to liquid state. Further, all of following statement are false, except gas molecule do not attract each other at very low temperature. Actual volume of a gas is not negligible at very high pressure. All of gas cannot be liquefied. Increase in pressure will not be decrease the intermolecular distance in a molecules. From these four options, the right option is B. Actual volume of a gas is not negligible at very high pressure. From question number 18, at the same temperature and pressure, helium is more ideal than hydrogen due to greater molar mass, greater molecular size, less molar mass, less molecular size. From question number 18, the option right option is D, less molecular size. For question number 19, a constant volume for a fixed number of mole of a gas, the pressure of a gas increase with rise in temperature due to increase in average molecular speed, increase in average molecular attraction, increase in rate of collision, increase in main free path. So the right option from these equation is C, increase in rate of collision. An ideal gas expand according to PV is equal to constant. One on expansion, the temperature of a gas will rise, will remain constant, will drop, cannot be determined because the external pressure is not known. So the right option is B, will remain constant. Slope of graph between the PV and P8 constant temperature is 1 by 2, 1, 0, 1 over V square. So the right option from these four options is C, 0. Under which of the following condition van der Waal gas approach ideal behavior? Extremely low pressure, high pressure, low product of PV, low temperature. So the right option is option A, extremely low pressure. In elastic collision of the two particle, the following is conversed speed of each particle, kinetic energy of each particle, total kinetic energy of both the particles, momentum of each particle. So the right option from these four options is C, or third option is correct, total kinetic energy of both the particles. Question number 24, Maxwell Boltzman law is for option A, distinguishable particle, indistinguishable particle, particle with half integral spin, particle with integral spin. So the right option is option A, distinguishable particles. Question number 25, the ratio of root mean square velocity to the most probable velocity is under root 3 ratio under root 2, B option 2 under root 2 ratio 3 under root, C option is 2, 3 ratio 2, and D option is 2 ratio 3. So the right option is A, 3 under root ratio 2 under root. What would be the most probable velocity for oxygen molecule at 300 Kelvin, 612 meter per second, 714 meter per second, 798 meter per second, and 821 meter per second? So the right option from these options is B, 714. You can add the value of most probable velocity formula and get the calculation which is equal to the option number B, 714 meter per second. Mass of A is 4 times than that of B. What is the ratio of their mean velocity? 1 ratio 4, 4 ratio 1, 1 ratio 2, 2 ratio 1. So the right option from these four options is D, 2 ratio 1. So, what is the root mean speed of the methane at 25 centigrade, 450 meter per second, 532 meter per second, 678 meter per second, and 745 meter per second? So, the right option from these four options is D, 745 meter per second. By getting this value from the root mean square velocity formula and adding the temperature 27 degree, then we can get the calculation which is 745 meter per second. Question number 29, the compressibility factor of ideal gas is 0, infinite, C option is 1, and D option is -1. So from these four options, the right option is C, which is 1. So the compressibility of ideal gas is 1. The curve represents CO2 is X, B is Y, C is both X and Y, D is cannot be predicted from graph. So the right option from these four option is B, Y. Question number 31. At high pressure, the compressibility factor Z is unity 1 plus PB over RT and 1 minus PB over RT, and other option is 0. So the right option from these four options is B, 1 plus PB over RT. Similarly, the compressibility factor Z for hydrogen and helium is usually greater than 1, is equal to 1, less than 1, or equal to 0. So the right option is A, which is compressibility factor for the hydrogen and helium is greater than 1. Question number 33. A spontaneous change in accompanied by dash of internal energy or enthalpy. The right option from these option is decrease. A spontaneous change is accompanied by internal energy or enthalpy will be decrease. Entropy is a measure of dash of the molecule of a system, concentration, velocity, zigzag motion, randomness, or disorderness. So the right option from these four option is D. Randomness or disorderness of a system is known as a entropy. The second law of thermodynamics state that whenever a spontaneous process occur, it is accompanied by a increase in total energy of a universe. The entropy of a system is constantly increasing, neither of the above, both A and B. So the right option from these four options, which is D, both A and B. The Gibbs free energy G is defined as G is equal to H plus Ts, G is equal to H minus Ts, and G is equal to Ts minus H, and D is none of these. So the right option from these option which is B, G is equal to H minus Ts. And which out of the following is not a state function? Free energy, work function, entropy, work done. This is common question. The right option from these four option is B. Work function is a not a state function. The Gibbs Hamato equation is applicable to the all process chemical or physical, or process chemical and physical, but in closed system, or chemical process in a closed system. And option D is all processes in a closed system. So the right option from these four options, all process chemical or physical, but system should be in closed. So the right option is B option. All process, even chemical or physical, but system should be in closed form. For a spontaneous process, Gibbs free energy is greater than zero. Gibbs free energy, yeah, or change in Gibbs energy is less than zero, or change in Gibbs energy is equal to zero. Fourth option is none of these. So the right option is A. Change in Gibbs free energy is greater than zero. The Clausius-Clapeyron equation help to calculate the latent heat of vaporization, boiling point or freezing point, vapor pressure at one temperature if at another temperature is given. D option, all of these. So the first option is correct. We only use the Clausius-Clapeyron equation to calculate the heat of vaporization. So this is our session. Uh, we will meet soon in next session.